Okay, welcome back. Rounding out Chapter 3, I do want you to know the electromagnetic spectrum, know the differences of low and high energy, which has the highest energy in the spectrum, which has the lowest energy, the highest wavelength, and the lowest wavelength. Also within the electromagnetic spectrum is your visible, your ultraviolet, area. This is the part that we can actually detect with our eyes, and the only part we can detect with our eyes. And they will be the colors of the rainbow. There's a way to remember those. You can write Roy G. Biv, which is a mnemonic for the colors of the ultraviolet, the visible range of the electromagnetic spectrum. Roy G. Biv is a mnemonic which stands for red, orange, yellow, green, blue, indigo, and violet. So do be familiar with that as well. Also know the electron energy levels as you go further down in the periodic table. Every period that you will go down, you will start a new energy level. Also within each energy level, you will have a sub-level which have the names S, P, D, and F. Know the shapes of your S and your P. Your S is your spherical-like shape, which looks like this. Your P has dumbbell shape in 3 different directions. You have one that's up and down, one that is left and right, and then one that's going to be going front to back, and we'll kind of represent that with a dotted line like this. And they are called your PX, PY, and PZ based on which actual plane that they are in. And there's 3 dimensions, so there's 3 of those. Also know the number of electrons held within each sublevel, your S, P, D, and F. How many electrons fit in each sublevel, and how many orbitals are within each level. And remember that the maximum number of electrons that can fit within each orbital is going to be 2 electrons going in opposite directions. So that leads us to orbital diagrams. Do know how to draw the orbital diagrams. The orbital diagrams, again, I won't give you something that is very long. This is going to be something like carbon or nitrogen. There are videos of that, so do take a look at those. And in a little bit different than electron diagrams, or orbital diagrams, is going to be your electron configurations. This is your 1s2, 2s2, 2p6, and so forth. Do know how to write the electron configuration notation of different elements. And also know the number that are in the highest coefficient represents the highest energy level, and within that highest energy level are going to be your valence electrons. So that leads us down to periodic trends. That should be periodic. Periodic trends within the periodic table are going to be valence electrons, the number of electrons in the outermost energy level. Also be familiar with the atomic radii of the different elements. Know when it increases and decreases as you go down and across the periodic table. And also know the general definition of ionization energy. Ionization energy, just like it looks, it's going to be forming an ion, so it's going to ultimately develop a charge. That does require an energy barrier to overcome. And what an ionization energy basically states is going to be the energy that it takes to take out the outermost valence electron within an element, ultimately giving a charge to that element. So do be familiar with that. Go ahead now and pause the video if you want to take down a few notes, and I'll see you back.